After making a stock solution and set of dilutions, transfer these into cuvettes using a transfer pipette. Also transfer water into one of them as a blank. Fill them up to the line marked on the cuvette so it will scan properly in the spectrophotometer. Make sure you have a system to remember which dilution is in which cuvette. Now it's time to use the spectrophotometer to determine the absorbance of the dilutions. Here's how the spectrophotometer works. The light of the chosen wavelength is emitted from the spectrophotometer. It passes through the solution. Some of the light is absorbed by the molecules in the solute. The higher the concentration, the more light absorbed. The rest of the light hits a detector. The detected final light, subtracted from the initial light, is the absorbance value the spectrophotometer displays on the screen. As concentrations of your dilutions increase, so will the absorbance value. You need to determine the best wavelength of light to measure your dilutions at. Use a cuvette of stock solution to do this. Scan across all wavelengths and the spectrometer will show a graph of absorbance versus wavelength. The lambda max is the highest peak, where the absorbance of the substance is highest. So you use the lambda max wavelength to measure your dilutions absorbances. The lambda max can also sometimes be used to figure out an unknown substance through comparison to known substances. Here's an example of the lambda max on the graph. Now you will need to zero the spectrophotometer with the blank. Clean two sides of the cuvette so the light will pass through. Do this using a Chem wipe. Open the spectrophotometer lid and place the cuvette so that the clean side faces the light source. Hit 0 on the computer. This is basically just a reference so that dilutions will have an absorbance value to be compared to. You only need to zero once before obtaining these values. For each dilution, clean two sides of the cuvette and place in the spectrophotometer. Make sure the cuvette is facing the right way before closing the lid. To read these absorbance values, press Read on the screen. Make sure to record all these absorbance values in your notebook. Be sure to remove cuvettes after readings and close the lid of the spectrophotometer. When creating a graph, the absorbance value should be the y-axis and the concentration value should be the x-axis.
The A stands for absorbance, which is what the spectrophotometer measures how much light is absorbed by the substance. Failing to zero the machine would mean that there would be no basic or blank absorbance value to base a comparison off of the absorbance values being read. The epsilon stands for molar absorptivity, which is just the slope of the line. You can find this by looking at your graph. You can also use the equation for slope, which is y2 minus y1 over x2 minus x1, using the y values of absorbance and the x values of the concentration.
Here's an example of the Beer-Lambert law. To find concentration values, use C1V1 equals C2V2. At the end of lab, clean all glassware and put them away in their proper location. Finish by wiping down the lab area and you're ready to go.
Happy birthday, Dr. Erdman! It's mole day!